Okay, so now that we've got our VFD, our electronics cabinet all connected, we've got the lathe running. Now it's just a matter of starting to do our mounts for our ball screws. First we're going to tackle the Z-axis so we can get this moving back and forth. And to do that, we've got to make some mounts to mount under our cross slide, and also an adapter to go onto our gearbox here. And so those are the things we're going to concentrate on first. So let's get started. Okay, so we've made our coupling. This portion right here goes on the shaft of the change gears. The bearing here rides on the end of the ball screw, like so. And then the ball screw will be able to turn freely. Very good design. It utilizes the shaft that's already there to keep everything centered. There are actually two bearings in here to give it a little bit more stability. It's just made out of aluminum, some 1-inch stock. Alright, so our coupling's made. Okay, so we've got our ball screw in and our coupling in. And so now I'm going to try to work on my mount here. I'm going to make a back plate right here. This is just going to be some 1/4-inch flat stock, and I'm going to work on it now. Okay, so now I'm working on the Z-axis stepper and ball screw bearing mounts, and this is a back plate. So let's cut it out. Got it loaded in Mach 3 and ready to go. Got a 3/8" end mill to do the side cleaning. Now we're doing a finishing pass. Line cutting. Okay, so we're going to start drilling our holes now. I've got 4 holes I need to drill. Got a center drill in here. Okay, I'm going to drill 4 holes. I'm using a 1/8 stub drill. This is 7 inches per minute, no peck. Okay, and now I want to enlarge these holes to a 1/4 inch. I've got a 2-flute 3/16" end mill. I'm going to spiral mill it. So now that we have our back plate made, the next piece is going to be our bearing block. There'll be 4 pieces total when we get finished with this bearing motor mount for the Z-axis. Here is a model that I drew up in SketchUp of the finished assembly, and you can kind of see how it's being pieced together. And so now let's start machining the bearing block. Okay, we're working on our bearing block for our Z-axis. Right now I'm squaring all 4 sides. I'm using a 3/8 inch end mill, 8 inches per minute at 0.02 depth of cut, 20,000. I'm actually going to be putting a small radius here and taking off about a 1/4 inch, and then putting a small radius here. Now I could have laid this flat and did a profile. However, this piece right here was almost exactly the right size, and clamping it up would have been a little difficult, so I decided to go this route. These are the tool paths that I'm going to be doing in my CAM program. I've got a couple of radius profiles which will be done with a 3/8 inch ball nose, and then the step will be taken care of with a 3/8 inch 4 flute end mill. We're going to do the pocket first. Okay, so we finished our step, and now I'm just putting in a ball nose, 3/8 inch ball nose, and we're going to run it down here and put a radius here, and then I'm going to round over this side. Start rounding over the end. Back drilling, 1/8 inch drill bit, 1/4 inch. So we've got our bearing block in here. We've already bored our holes to mount our spacer, and now we've just got to put a pocket for our bearing. And the first thing I did was took a scrap piece and put a pocket in here to make sure that we've got our diameter just right. It's not a press fit. And now just got to go and repeat the same pocket inside our bearing block. scuffing out the recess of the bearing. Okay, and we're going to go back now and we're going to finish it with a 4-flute 3/8 inch end mill. Okay, looks good. See what kind of fit we got. Perfect. Bearing just slides right in and it's flush. Very, very happy with that. I don't need it to be a press fit. I just need it to go in there. I think that's perfect. Alright, so now I'm just going to surface the top of this just to clean it up. The trick's going to be when we flip the bearing block over, getting the bearings lined back up. Okay, so we've got our bearing pocket on the other side. Milled out. And again, the bearing just kind of drops right in there. Very nice. Now we need to cut our finished bearing block. Turned out really nice. Very satisfied with the finish. There are a couple different ways I could have machined it. I could have just mounted a block into the mill and then did the profiles and everything. But because I already had a piece that was just about the right size of stock, I chose to do it the way you saw in the video. It probably took me a little bit longer, but it's okay. It turned out really smooth and really nice. I'm very satisfied with it. We'll have a standoff that goes right here, and then this will go towards the headstock, and it'll just slide in like so. And mount to the back plate. You may not be able to see this, but the block is not exactly flush with the end of the backing plate, and if I slide it out, that's going to create, if you'll look right here, that's going to create a little play, which is going to cause backlash. So my solution for that is I can either cut a spacer on the coupling side, or what I'm going to do is put these Belleville washers in there. These are real thin disc shaped washers, and when you put two of them together like so, it creates a gap in the center. I'm actually going to turn them opposite so that there's a gap like that, and it'll touch the outside of each, the bearing and the race inside, and then those will squeeze together and give me the spacing that I need. So I'm just going to drop these in there like so, and then that will give me the pressure to keep everything pushed up against the, now it's not at the end of the, and I can push on it, and that'll give me tension. So that's that piece. Now the next piece that I'm going to work on is the actual standoff, and then we're going to work on the mount for the stepper motor. So let's get started. We're milling the standoff. So we're going to be cutting a slot in our tubing here to allow for us to get in there with a Allen wrench and tighten up our coupling. So let's get started. We've got a 2 flute 3/8 inch end mill. Turned out really nice. Moving right along. Okay, so now we have our standoff made. It's just some square tubing, and it will fit in that square pocket that I made. And these 4 holes will actually bolt to the backing plate. And then I'll actually bolt through here with 4 holes that you saw here. That'll hold everything together like so. And then now you'll be able to access the coupling through here and tighten up the set screws. So that's piece 3, and now we just have to do the stepper mount. I'll probably come back and maybe clean this up and surface it to get a nice finish. I haven't decided yet. It's not that critical. So now let's go make the stepper motor mount. Okay, so we're going to be doing our stepper mount for our Z-axis, and we've got a pocket and a recess, and we're going to be boring 8 holes. Of alcohol. Try to keep it cool. Okay, so now we have our stepper mount milled out, and it's going to just go like so, and then our motor will fit on there. Our motor fits on. I still need to tap these holes to mount the motor, but now our motor mounts like so. And then our standoff goes on there like this, and then that bolts onto our whole assembly like so. If I can get it in the hole here. Well, need 3 hands. Okay, there's that. Goes in there like that. So, there we go. And then the whole thing will just kind of mount like so. And then we'll push it in, get that tight, take all the backlash out of it. And that should be it. So now what I want to do is I want to drill and tap those holes and get everything mounted together and wrap up this mount. just adding a little finishing touch to the part here. Kind of like the logo I just kind of came up with, and thought it was pretty neat. So I don't know if you can see it, but just using the TTS diamond engraver. Alright, so this piece is done. I didn't bother doing the back, but just did the top and the front. Alright. Okay, so I'm drilling and tapping the 4 holes. Just using a cordless drill. Back and forth. You only got to go about 3/8, 5/16, something like that. That's about it. These are M3 by 5. M3 by 0.5, I'm sorry, threads per inch. Alright, and that's it for tapping. Okay, so I got it clamped in here now, and I'm just going to cut these corners and clean up these edges. Hey guys, alright, so I got the back plate mounted with these 2 screws. These are M6, just some countersinks. They're in the same position as the original bolts for the bearing block that was there. And I'm also using the same bolts from the back side to mount the bearing block. Now I showed you earlier there was a little play in between the bearing and the ball screw, and it allowed just a little bit of flex, and I didn't want that backlash in my Z-axis. Now there were a couple of ways I could have got around that. There's just no way that I could, in my mind, machine something that was the exact distance. So rather than try to get it perfectly distanced away, what I did was I installed these Belleville washers, and They're just real thin washers. Basically, it is the same type of washer that we use on the power drawbar. They're disc shaped, and they bend. And so what I did was, inside the bearing race, I stuck them like so, 2 of them, and that left just a little gap right there, and allowed just for a little flex. And that has taken up all the backlash that was in there, and everything's nice and tight now, and it'll keep that pressure on there all the time with those washers in there. Now, there are several ways I think that taking up the backlash could have been accomplished. I chose this method because I had some of these Belleville washers, and I thought it was the simplest and easiest thing to do. Another alternative would be to slide the coupling over away from the tailstock and put a set screw in here. Over time, the set screw could loosen up and wear, and I didn't want to mar the little shaft that was sticking out. So I decided to do the Belleville washers. Now my coupling goes all the way up against my headstock here, and it's just tied up against there. There is no pin or anything. I just didn't feel like it needed a pin. It's a nice fit, nice tight fit on there, and so everything's just pressed up against there. And if the ball screw happens to get any backlash with usage over time, you can just simply add another Belleville washer. So that took care of that, and now I just have to mount this on, and we can get the stepper motor mounted. I went ahead and cleaned up these edges and rounded them over and got them real nice, and turned out good. And so now we just got to mount this. So let me get that mounted. Well, okay, here's the finished Z-axis mount. Got everything mounted and bolted together. I really like the way it turned out. The finish is nice, the fit, everything bolted up perfect. It's extremely sturdy, and I don't think it's going to give me any trouble. And hopefully it'll give me many years of service. The Belleville washers really did the trick, and I shouldn't have any problem with backlash. And if I do in the future, I can always add one of those washers. So we're going to route the wire. Of course, it'll just be, the cabling will just be routed back behind the lathe and out of the way. So that's good. So the next thing we've got to do is we've got to work on our mount for our apron so that the ball nut will have something to attach to. Like so. It'll attach down here and move the whole assembly forward and back. A lot goes in just to the one Z-mount. The Z-mount's the most complicated, I think, because it has the most pieces. So we'll tackle that next. Get this apron right here worked out, and we'll start on it in the next video. So there's our Z-axis stepper motor mount. Very happy with the way it turned out. Thanks for watching the video. Please subscribe to the YouTube channel. Feel free to leave any comments or suggestions. If there's anything that you felt like I missed or left out, please leave me a comment and I'll try to include it somehow in one of the other videos. Have a great day.